Back in the early 2020s, a specific vision of the energy transition dominated the narrative. Hydrogen was marketed as the Swiss Army knife of the future, a versatile molecule capable of powering everything from residential heating to the family commuter car. By 2026, that universal dream has met the reality of the consumer market. Honda has permanently ended production of its flagship hydrogen SUV, the CR-V FCEV, following a period of low adoption and a significant safety recall. The surviving passenger models, like the Toyota Mirai, have retreated into a highly specialized luxury niche. With prices often exceeding $50,000 and an extremely sparse network of public pumps, they remain a rare sight on the road. The struggle of the hydrogen commuter car isn't a failure of engineering. The fuel cell systems operate exactly as they were designed. The barrier is much more fundamental, a hard limit imposed by the laws of thermodynamics. Efficiency is lost at every stage of the hydrogen cycle. To move a fuel cell vehicle, you have to use electricity to split water, compress that gas to extreme pressures, transport it to a station, and finally convert it back into electricity on board. By the time that energy reaches the wheels, the total system efficiency is trapped between 40 and 50%. Standard battery electric vehicles follow a much shorter path. Because they store power straight from the grid directly into a lithium-ion battery, they bypass those intensive chemical conversions. The result is a system that retains 90% of its initial energy. Despite these efficiency penalties, the Indonesian government is classifying hydrogen as a strategic energy source. They are currently investing in projects designed to integrate hydrogen into 12% of the national energy mix by 2060. This isn't a rejection of physics, it's an acknowledgement that hydrogen is no longer being asked to compete in the driveway. It has been moved to a different battlefield entirely. The Class 8 heavy freight industry is defined by two requirements: moving massive weight and covering long distances without stopping. In this sector, every pound of the vehicle matters. This creates a significant problem for battery technology. To move a fully loaded semi-truck 1,000 kilometers on a single charge, the required lithium-ion battery pack would weigh tens of thousands of pounds. Because commercial trucks must stay under strict legal weight limits, every ton of battery is a ton of paying cargo that the fleet cannot carry. For a logistics company, that extra weight translates directly into lost revenue on every single trip. The physical mass that makes batteries ideal for light city cars makes them a significant economic burden for heavy, long-haul logistics. Hydrogen offers a different physical trade-off through gravimetric energy density. It's the lightest element in the universe, yet contains immense energy per kilogram of mass. Modern engineering utilizes this by using 700-bar aerospace-grade composite tanks. These high-pressure cylinders allow a truck to carry up to 100 kilograms of fuel, while keeping the fuel system's total weight much lower than a comparable battery pack. The result is a vehicle that delivers over 600 horsepower and a 1,000-kilometer range, while matching the 20-minute refueling time of a diesel engine. It allows zero-emission shipping without requiring the operator to sacrifice their cargo capacity. For the freight industry, hydrogen is currently the only zero-emission fuel that doesn't force a compromise on the fundamental business model of shipping goods. The primary hurdle is the initial price. Currently, a fuel cell truck costs roughly 3 times as much to manufacture as a battery electric version, largely due to the cost of the high-pressure tanks and the platinum used in the fuel cell. However, when we look at the total cost of ownership across the vehicle's entire life, the math begins to shift. While the purchase price is high, the ongoing maintenance and operational costs tell a different story. Hydrogen drivetrains eliminate oil changes, timing belts, and complex transmissions. By using magnetic regenerative braking, they also experience much less wear on their brake pads. Lifetime maintenance for an electric motor averages around $4,600, while the compounding repairs on a traditional diesel engine can exceed $9,200. When fleet owners factor in the protected cargo revenue and significantly lower maintenance requirements, the long-term economic case for hydrogen and heavy freight becomes clear. Indonesia is applying this logic to its national infrastructure. By 2026, the focus has moved away from building general-purpose retail pumps for the public. Instead, the state utility PLN has opened the Senayan Hydrogen Refueling Station in Jakarta. This facility is specifically engineered with 700-bar compression systems, designed to service the heavy commercial trucks and logistics fleets moving through the city's strategic corridors. By placing high-capacity stations directly on commercial routes, the government provides fleet operators with the physical certainty they need to begin retiring their diesel assets and investing in hydrogen-powered replacements. To fuel these logistics hubs without relying on imported energy, Indonesia is pivoting toward domestic green hydrogen production at an industrial scale. In Sumatra, Pertamina's Ulubelu geothermal pilot plant is now testing the extraction of green hydrogen using the constant, reliable heat of the country's volcanic geography. At the same time, projects like the Sarimukti Waste-to-Hydrogen site in West Java are exploring how to reform organic waste into fuel, creating a diverse, decentralized supply chain. These projects allow Indonesia to use its own geography to secure a domestic energy supply, reducing the need for foreign fossil fuel imports. Hydrogen's journey over the last few years has seen it transition from an overgeneralized consumer promise to a specialized industrial tool. It hasn't failed the energy transition, it has simply moved to where the physics make it most effective, away from the residential driveway and into the industrial supply chain. By focusing on the heavy-duty logistics that sustain modern cities, hydrogen has moved into a role that batteries cannot fill, providing a practical pathway for the most difficult sectors of the economy to decarbonize.